let's take a look at the next page here. So angles L and M are intersected by transversal T. Lines L and M are intersected by transversal T. L is parallel to M. Yeah, they got it right this time. L is parallel to M. T's are transversal. It says by which postulate postulate or theorem is angle 1 congruent to angle 8? So angle 1 is located here. And if they're congruent, we know that these angles are going to be equal to each other. So now we just kind of identify where are these angles located on our diagram. Well, we can see that they're on the opposite sides, or one is on one side of the transversal, one's on the other. So that's going to tell us that we have alternate angles, but where are they in relation to the parallel lines? Well, we can see that one is above, one is below. They're outside of the two parallel lines in between. So they're outside of those. So these are alternate exterior angles. Okay, so this would be our alternate exterior angle theorem. That tells us that angles 1 and 8 are congruent. Let's take a look at number 4. So for number 4 here, we've got this triangle here. We're looking for the value of x. So we're looking for this angle here. So this is the angles inside of a triangle. Now we remember that they are our triangle angle sum theorem. Triangle angle sum theorem. Our triangle angle sum theorem tells us that the angles inside of a triangle have to add up to 180 degrees. So we would know that if we have angle x plus that 43 degree angle plus the 75 degree angle, all of those have to add up to 180. So let's combine our like terms. So x plus, well, 43 and 75. Okay, let's turn that on. 43 plus a 75, that's a 118. Okay, 118, and that's equal to 180 altogether. But let's get that x by itself by subtracting 118 from both sides of our equation. So our x, let's see, is going to be 180 minus the 118. In this case, we're going to get a 62. So we get 62 degrees. Okay, put a box around it because we're done. Let's take a look at our next one. Now, number 5, it says in triangle ABC, the measure of angle A is 75, measure of angle C is 20. What's the measure of angle B? Well, this is basically the same kind of a problem that we just saw here of our triangle angle sum theorem, where all of the angles add up to 180. They just didn't give us a picture this time, but that's okay, because we know that if we took angle A plus angle B plus angle C, all those would have to add up to 180 because it's inside of a triangle ABC. So let's just substitute the values that we have. Well, we know that angle A, measure of angle A is 75, measure of angle C is a 20. So let's substitute those in. So we've got a 75 plus our angle B, okay, plus our 20 degree angle is going to be 180. So once again, we're going to combine our like terms, 75 and 20. Well, that's just a 95. So we know that we've got angle B plus 95 equals 180. So let's subtract 95 from both sides. Okay. So subtracting 95 from both sides, we've got 180 minus the 95, and that's 85 degrees. So our angle B is 85 degrees. Okay, put a box around it, because we're done. All right, next one, number 6. What is the equation of a line perpendicular to the line y equals 2x plus 1 and passing through the point 4, 6? Now this is an interesting kind of a problem. Now the first thing we have to know that for an equation of a line that's perpendicular. Now remember that perpendiculars, we should see opposite reciprocal slopes. I can't spell here. Okay, should be opposite reciprocal slopes. So right now we can see that from our slope-intercept form, y equals mx plus b, our m being our slope, in this particular case, we have a slope of 2. Well, let's think about what the opposite reciprocal of that is. Well, if we know that the parallel slope is a 2, or a 2 over 1, our perpendicular slope is going to be the opposite of a positive. In this case, it's negative, and instead of 2 over 1, it's 1 over 2. So we're going to use this here. So we need a slope that has a negative 1/2. So immediately we can see that it might be letter A here, because we have a negative 1/2 slope here, or it might be a negative 1/2 slope here for C. It can't be B or D, because these two have a slope of 2. These two lines are actually parallel to the original line. So now we've got it narrowed down to our right, to our wrong. Well, now we have to figure out which one is which. Now, how do we do this? Well, remember that they gave this point 4, 6. Now, 4, 6 is a coordinate. This is our x and y. So what we're going to do is put each one of these values into each one of these equations and see which one gives us a true statement. Okay? So let's try the first one. So if we try A over here, we have y equals negative 1/2 x plus 6. So y is a 6. And is that actually equal to a negative 1/2 times the 4, which is our x, plus 6? Well, let's think about this for a moment. Okay? Well, I've got a negative 1/2 of a 4. Well, negative 1/2, so that's a negative 1/2, okay, times a 4. Well, that's a negative 2. So on this side, we're going to have a negative 2 plus a 6. Well, negative 2 plus a 6 is a 4. And is 6 equal to 4? Absolutely not. This is false. Okay? So it can't be A. But let's just verify to make sure if it's C or not. So if we try C over here, okay, we've got our y equals a 1/2 x plus 8. So our y is the 6. And we're going to see, is that equal to a negative 1/2? The x, once again, is a 4, okay, plus an 8. Okay, so let's figure this out. Well, we saw that negative 1/2 times 4 was a negative 2. But if we add 8 to that, what do we get? Well, a negative 2 plus an 8 is a 6. And 6 does indeed equal 6. So this is true. Therefore, it has to be C. Okay, so we can figure out whether or not these lines are perpendicular or parallel even without graphing this.